Imagine trying to hit a sniper's bullet with another bullet. You're in pitch darkness, traveling at like 5 times the speed of sound, and you have to make contact with millimeter precision.
Right.
Now imagine walking into a room full of government accountants and trying to convince them to authorize the construction of 2,000 of those hyper-advanced systems every single year for the next 7 years.
Yeah, that's a tough sell.
Welcome to another custom-tailored deep dive. Our mission today is to explore a massive, fundamental shift in how the military buys technology. And, we're using one specific, incredibly complex piece of hardware to really understand how this entire system is changing.
And we have a really revealing stack of sources for this analysis, actually. We're looking at a January 2026 press release directly from the U.S. Department of War, and we're pairing that with a highly technical presentation from Lockheed Martin.
Yeah, the Lockheed doc is wild.
It really is. It outlines the exact aerodynamic and physical specifications of their defense systems. It's very dense.
For you listening, the goal here is to connect the dots between these boardroom acquisition strategies and the raw physics of intercepting a missile in midair. We're going to figure out what the government is buying, how they are completely rewriting the rules of how they buy it, and why this shift matters to you and the broader global landscape. Okay, let's unpack this.
So to fully grasp the hardware, we really have to look at the economic engine driving it first. The Department of War recently made this landmark announcement. They established a 7-year framework agreement with Lockheed Martin to dramatically scale up the production of a specific missile interceptor.
Right, the PAC-3 MSE.
Exactly. The PAC-3 MSE, that stands for Missile Segment Enhancement.
I was looking at the numbers in the release, and the scale of the jump is what really caught my eye. They're moving from producing around 600 of these missiles a year to approximately 2,000 a year.
It's massive.
You don't just, flip a switch on a factory floor to more than triple the output of something this complex.
No, absolutely not. The industrial logistics of that kind of jump are staggering. And that challenge is the core focus of the new acquisition transformation strategy,
Which was unveiled by the Secretary of War in his Arsenal of Freedom speech, right?
Right. The central directive of this strategy is to stabilize demand signals. Because historically, defense procurement has been this really frustrating start-and-stop process. It's plagued by annual budget battles, shifting political priorities.
Which is where something I noticed in the text comes into play. The press release kept highlighting the creation of a Munitions Acceleration Council.
Yes.
And at first glance, that sounded like standard, bloated bureaucratic jargon to me. But based on the context, it seems their entire job is to essentially act as a bulldozer for red tape.
That is their exact mandate, yeah. They are tasked with removing the structural barriers that usually slow down weapons production. And the reason a bulldozer is necessary comes down to a fundamental economic concept called demand certainty.
Okay, break that down for us.
Well, if we look at this from the perspective of the defense industry, scaling up production isn't just about hiring a few more workers. It requires a process called facilitization.
Facilitization, meaning building the actual physical capacity to make the thing.
Precisely. It's the opposite of a quick fix. Facilitization means designing and constructing massive new, highly specialized factories.
Oh, wow.
Yeah, it means building environmentally controlled clean rooms for guidance electronics, securing these huge testing chambers for radar seekers, and establishing completely new supply chains for raw materials.
So we're talking big money.
Billions. It requires billions of dollars in upfront investment.
I think I see the friction here. You can't ask a private company to sink $1 billion into a custom-built rocket factory on the mere hope that the government might decide to buy more missiles next year.
Exactly.
If the budget gets cut, the company is left holding the bag on a massive, empty facility.
The risk profile is just too high for any rational business to take on without guarantees. Without long-term contracts, defense companies cannot justify the massive upfront costs of facilitization. But this new 7-year framework completely alters that dynamic.
House.
By guaranteeing long-term growing demand, the government actually shares the financial risk. It incentivizes the industry to invest their own capital into expanding capacity. So it aligns the interests of the taxpayers, the government, and the industry to drastically cut lead times.
Let me try to visualize this for a second. It's a bit like a local bakery.
Okay.
If I go in and order one custom cake a week, they're just going to use their normal oven in the back.
Yeah.
The process might be slow, but, it works for that volume.
Sure.
Now, if I suddenly demand 100 cakes a week, they can't just work faster. They need a commercial kitchen. But they aren't going to take out a multi-million-dollar business loan to build that kitchen unless I sign a legally binding contract guaranteeing I will buy those 100 cakes a week for the next 7 years.
That captures the boardroom reality perfectly. The government is finally committing to acting like a predictable long-term customer.
Makes sense.
The Undersecretary of War for Acquisition and Sustainment actually referred to this as a fundamental shift in collaboration. They're recognizing that you cannot have an arsenal of freedom if the factories building it are constantly worried about going bankrupt next quarter.
Right. But knowing that the government is buying 2,000 of these a year doesn't tell us why this specific missile is worth completely rewriting the procurement playbook. I mean, there are plenty of weapons out there.
True.
To understand the economics, we actually have to look at the physics of the hardware itself.
And the Lockheed Martin technical data makes a very strong case for why the PAC-3 MSE is considered the world's most advanced air defense missile.
It's quite the read.
3 major physical components stand out immediately in the documentation, starting with the 2-pulse solid rocket motor.
I want to break these down because the engineering is wild. A 2-pulse motor means it doesn't just burn all its fuel at once to get off the ground. It manages its energy dynamically.
Right. The first pulse gets the interceptor out of the launcher tube and accelerates it to hypervelocity speeds, pushing it high into the atmosphere.
Okay.
But as it approaches the target, it might need to make a sudden, drastic maneuver. That's when the second pulse ignites, giving it a massive burst of energy and velocity precisely when it needs to outmaneuver an incoming threat in that terminal phase of the flight.
So it's literally saving a turbo boost for the final second.
Exactly.
And to guide that boost, the presentation highlights an active Ka-band radar seeker. Now, for anyone not deeply steeped in radar technology, Ka-band refers to a specific, very high frequency of radio waves.
Right, very short wavelengths.
Because the wavelengths are incredibly short, it provides millimeter-level precision. It's the difference between navigating a pitch-black room with a blurry wide-beam flashlight versus scanning the room with a highly focused pinpoint laser.
That's a great way to put it. The missile is essentially doing its own high-speed computing. It isn't just receiving instructions from the ground. It is actively sensing the threat, calculating range rate, and angle data in real time. It actually sees the physical shape of the incoming target.
That's crazy. And then there's the airframe itself. It uses forward-mounted attitude control motors.
Yes, the ACMs.
These are little side-firing thrusters mounted near the front of the missile.
Yeah.
At the altitudes these intercepts happen, the air is too thin for traditional fins to steer the missile effectively.
Right. Fins wouldn't do anything up there.
So it uses literal miniature rockets to violently snap its nose toward the target.
The combination of that dynamic 2-pulse energy, the hyper-precise Ka-band vision, and the twitchy maneuverability of those side thrusters all exist to serve one core defining philosophy of this missile.
Which is?
The transition from traditional blast fragmentation to hit-to-kill technology.
Okay, I want to push back on this concept for a second because intuitively it feels backwards to me. Older defense systems, the blast fragmentation ones, essentially flew up to the incoming threat and detonated a massive explosion near it.
Right.
Like a giant flying shotgun blast.
Yeah.
Why go through the agonizing engineering challenge of physically ramming into a target, literally hitting a bullet with a bullet, when you could just detonate a massive explosive charge in its general vicinity?
That is a very common question, and the Lockheed presentation addresses that exact skepticism using something called hydrocode analysis.
Oh man, the hydrocode stuff.
I love this part. It is a phenomenal way to illustrate the raw physics at play here.
I saw the hydrocode charts in the notes. It looked like a supercomputer simulation of a car crash, but Mach 5.
That is essentially what it is. Hydrocode is a computational tool used by engineers to simulate the complex dynamics of high-speed impacts down to the microsecond. When researchers run a hydrocode analysis on a traditional blast fragmentation intercept, the data reveals a severe limitation. The explosion, while massive, only delivers a few megajoules of energy directly onto the target.
Right, because the explosion happens in the open air. The energy dissipates in a 360-degree sphere, so only a tiny fraction of that blast wave actually hits the incoming missile. You're basically relying on a random piece of flying shrapnel to hit something vital and cause a mission kill.
Exactly. And the contrast becomes clear when you run the analysis on a hit-to-kill intercept. Because the PAC-3 MSE relies on direct body-to-body contact at hypervelocity speeds, it delivers hundreds of megajoules of kinetic energy directly into the threat.
Here's where it gets really interesting. We're comparing a few megajoules from a proximity explosion to hundreds of megajoules from a kinetic impact.
It's not even close.
We aren't just talking about a slight upgrade in lethality. We are talking about an exponential, massive difference in the sheer violence of the intercept. Hundreds of megajoules is the equivalent of a fully loaded freight train hitting a brick wall, but concentrated entirely into an 11-inch diameter metal dart.
The kinetic energy transfer is so profound that it physically alters the material state of the incoming threat.
Wow.
The friction and force overwhelm the structural integrity of the target metal instantly. It is absolute certain destruction versus a probable mission kill from a piece of shrapnel.
Which naturally leads us to the aftermath. We know it hits exponentially harder in the sky, but, gravity is relentless. How does that raw kinetic energy actually translate to safety for the people and infrastructure standing on the ground?
That is the crucial question, because hitting the incoming missile is only half of the engineering challenge. The other half is ensuring you don't destroy the very thing you were trying to protect with falling flaming debris. We have to look at the end game of both systems, particularly when defending against complex threats like a tactical ballistic missile or TBM.
Just for context for you listening, a tactical ballistic missile isn't always just one giant explosive. Often it's essentially a hollow bus carrying a payload of submunitions.
Exactly.
Dozens of smaller individual bomblets packed inside the main shell, designed to scatter over a wide area.
And when we look at the hydrocode data for a blast fragmentation intercept against a TBM, the timeline of the explosion reveals a critical flaw. The proximity fuse detonates the blast frag warhead, the shrapnel flies outward and typically shreds the aeroshell, that's the outer skin of the ballistic missile.
Right.
But the kinetic energy of that shrapnel usually doesn't penetrate deeply enough to destroy the payload.
So you've essentially just cracked open the shell midair, but the lethal payload inside those dozens of submunitions survives the blast.
Yes. The data shows most submunitions either survive completely intact or sustain moderate deformation.
That sounds terrible.
It is. The debris field continues to propagate downward onto what the military calls the defended asset. You may have successfully stopped the main missile body from hitting its precise target, but you have inadvertently rained explosive collateral damage all over the effective defended area below.
What's fascinating here is how the physics of hit to kill completely rewrites that dynamic.
Totally. The mechanism of destruction is entirely different. When the PAC-3 MSE impacts that same tactical ballistic missile, it delivers those hundreds of megajoules of kinetic energy directly into the nose of the threat.
Head on.
Right. And the shock wave of that impact doesn't just break the aeroshell, it propagates through the incoming missile. It physically crushes and vaporizes the submunitions before they can ever scatter.
It's less like swatting a water balloon midair and getting sprayed with the payload. It's much more like two bullets colliding perfectly head-on. The kinetic energy is so overwhelming that the bullets don't just break apart into dangerous pieces. The sheer force and friction literally melt and vaporize the metal on contact, turning a highly lethal warhead into a cloud of harmless dust.
And the analysis proves that out. After a hit-to-kill intercept, the ballistic trajectory of any remaining microscopic debris is generally unchanged, or the debris is rendered completely aerodynamically unstable and harmless.
So it doesn't fall on what you're protecting.
Exactly. It prevents lethal effects on the ground. Against modern, complex threats carrying submunitions, delivering that massive shock of kinetic energy is really the only way to genuinely protect the defended asset and minimize collateral damage.
We've established that this is an incredibly clean, unimaginably powerful intercept technology. But, this isn't just about protecting a single radar station or one specific city. The deployment of this technology is part of a massive global ecosystem.
Yes, it's huge.
Which actually brings us full circle back to the boardroom. It explains exactly why the Department of War is taking on the monumental task of jumping from 600 interceptors a year to 2,000.
Because the scale required is global. The PAC-3 international user community currently consists of 16 partner nations. This spans across critical geopolitical zones in Europe, the Middle East, and the Asia-Pacific.
That's a massive footprint.
It is. We are talking about an expansive network relying on this specific technology for their sovereign defense.
And if you're trying to manage an air defense grid across 16 different nations, you can't rely on rigid infrastructure. You need flexibility. That brings us to the M903 launcher upgrade detailed in the Lockheed files.
Right. The M903 launcher is a vital piece of this logistical puzzle. It was designed to allow for a highly modular mix of loadouts. Nations often have stockpiles of older missiles, like the PAC-3 CRI.
Which stands for Cost Reduction Initiative, right?
Yes. And the M903 can hold 16 of those older CRIs. Or it can hold up to 12 of the new, highly advanced MSEs. Crucially, it can hold a mixed configuration of both simultaneously.
It's basically plug-and-play architecture for global air defense. You load the launcher with whatever mix of interceptors the specific threat environment demands.
Now, if we connect this logistical flexibility to the bigger picture, the Department of War's new acquisition strategy comes into sharp focus. The U.S. government isn't just buying 2,000 missiles a year to fill its own warehouses. They are consciously acting as the anchor tenant for a massive international supply chain.
An anchor tenant, like a massive department store at a shopping mall.
That's a good analogy.
Their sheer size and guaranteed footprint bring in enough foot traffic and stability that all the smaller, specialized boutique stores around them can survive and thrive.
And the press release explicitly outlines this mechanism. By committing to this 7-year framework, the Department of War is providing demand certainty not just to the prime contractor, Lockheed Martin, but cascading that certainty down the line.
Down to the smaller guys.
Right. They are issuing 7-year subcontracts to the smaller sub-tier suppliers. These are the companies forging the specialty metals, manufacturing the Ka-band radar dishes, and building the solid rocket motors. They are ensuring the entire industrial base expands in unison.
Which means all 16 partner nations can actually rely on that supply chain being there when they need it most.
It allows the U.S. and its allies to maintain a critical strategic metric known as magazine depth.
Magazine depth.
Yeah. In a world where adversaries are increasingly capable of launching mass air raids featuring dozens or hundreds of threats simultaneously, having the most technologically advanced missile in the world doesn't matter if you run out of them on day 2 of a conflict.
Right.
Magazine depth means having the sheer volume of interceptors required to outlast a sustained, prolonged attack.
Why should you, listening to this right now, care about launcher loadouts and magazine depth? Because when you read the news about global defense or rising tensions across various continents, you're usually just seeing the tip of the iceberg. You see the dramatic political statements or the finalized treaties. But what's really keeping the peace, what's actually providing a credible deterrent, is this massive underlying logistical machine. It's the invisible architecture, making sure the right 11-inch diameter kinetic dart is sitting inside the right M903 launcher, fully supplied and ready to go at a moment's notice anywhere in the world.
The bureaucracy and the supply chain are just as vital to national security as the rocket motors and the radar seekers. You don't physically see the 7-year subcontracts or the billions spent on facilitization, but you absolutely see the results when those systems are tested and the skies remain clear.
Let's take a breath and recap the journey we just took through these sources. We started in the boardroom, looking at a revolutionary 7-year acquisition framework designed by the Department of War.
Yep.
We saw how establishing demand certainty cuts through red tape, shares financial risk, and allows the industrial base to drastically boost production from 600 to 2,000 interceptors a year.
And from there, we looked under the hood of the PAC-3 MSE to understand why the government was making that investment in the first place. We explored the staggering difference between the few megajoules of a traditional blast fragmentation warhead and the hundreds of megajoules of raw kinetic force delivered by a hit-to-kill impact.
We saw how that kinetic shockwave solves the gravity problem. It violently crushes and vaporizes incoming threats, preventing lethal submunition debris from raining down on the very people and assets we are trying to protect.
Right.
And finally, we zoomed out to see how modular systems like the M903 launcher scale that exact protection across 16 different allied nations, acting as a deep global magazine against mass raids. So what does this all mean?
It highlights a profound reality about modern innovation, I think. The limiting factor for deploying world-changing technology is rarely the physics or the engineering. Often the ultimate bottleneck is the bureaucracy of procurement.
Yeah, the paperwork.
Exactly. But when a massive entity like the government aligns its purchasing power with the harsh economic realities of the industrial base, they can move mountains.
Which leaves us with a fascinating broader question to mull over. The Department of War is using this new long-term acquisition model to successfully clear structural barriers and rebuild the defense industrial base.
Is working.
If this strategy of stabilizing demand signals works to rapidly scale up hyper-complex, vital technology for the arsenal of freedom, What other stagnant bureaucratic bottlenecks in our society could be cleared overnight if the government simply promised to act like a reliable, long-term customer?
That's a great question.
How many other critical sectors, like green energy infrastructure or semiconductor manufacturing, are just waiting for their own version of demand certainty to finally build the future?
The data certainly proves the anchor tenant model works when the stakes are high enough.
It absolutely does. Thank you for joining us on this deep dive. Keep looking past the headlines, keep following the supply chains, and as always, keep questioning the world around you.